All right, today we're breaking some PLA. I have 4 types of PLA from ELEGOO, DEEPLEE, PLA, PLA Plus, Matte PLA, and Rapid PLA Plus. And we're going to see how much force it takes to break each one of them. This is Make or Build It, and today we're testing 4 types of PLA from ELEGOO DEEPLEE. We have PLA, PLA Plus, Matte PLA, and Rapid PLA Plus. We're going to actually put them into our rig and measure how much force it takes to break each one. Now, I know in my last video on stress testing glues, you guys gave me a little bit of grief about using a more scientific method than me just snapping it in half or pulling things apart. So I designed a bridge that we're going to use in our jig, made of each types of these PLAs, to test how much force it takes to break each one. But it took me a while to design the bridge. I had to go through various different iterations before I found one that fit perfectly. Now let's get these printed in each one of these types of materials so we could get them tested. I wanted a consistent way to test this, so I printed all the bridges in the different type materials with the same amount of walls, which was 4, and the same amount of infill, which was 15% in a grid pattern. The idea, we're going to place the bridge in the vise and see how long each one takes to snap. There's no fancy tricks here, it's just PLA versus force. The force gauge will press down on the middle of the bridge and we'll see which one holds up the longest. So a quick science break. Force is measured in newtons, which is the amount of force needed to accelerate a 1 kilogram object by 1 meter per second squared. Basically, force equals mass multiplied by acceleration. In simple terms, the more newtons it takes to break the bridge, the stronger the material is. System, which is what we use in America, force is measured in pounds force. That's where 1 pound of force is required to accelerate 1 pound of mass by the Earth's gravity, which is 32.174 feet per second squared. Now, enough about science. Let's get these bridges off the printer and get them tested. So this DEEPLEE filament printed really nice for an inexpensive filament. Look how clean these are. Wow, I'm really impressed. All right, let's remove the supports. Super clean bridges. All right, let's get these tested. So in Bamboo Lab Studio, I had to create a custom filament in order to handle the PLA Plus because they didn't have any generic PLA Plus. And I was easily able to do that and set up this DEEPLEE filament. And as you can see, the PLA Plus printed really nicely, as well as the PLAs. I was really impressed with the quality of the filament and the way these prints came out. So I'm also really impressed with the color palette. For an inexpensive filament, I mean, this DEEPLEE filament performed really, really well. No issues whatsoever in Bamboo Lab Studio printing on my X1 carbon. So let's talk about what we're testing. Each of the filaments have different purposes and different properties. So PLA is your general purpose filament, and it's used for things like figurines, toys, and decorative items, or maybe even prototyping. It's usually not the strongest, so I'm guessing this one is going to break first. Now the PLA Plus should be a step up. It has additives that make it stronger and a little less brittle. It's great for functional parts that need a little more durability, such as brackets and enclosure. I'm expecting this one to hold up a little bit better than the PLA. The Rapid PLA Plus is similar to the PLA Plus, but it's designed to print quicker. Now, supposedly, it should have better layer adhesion, which may actually make it perform better in this test. The Matte PLA looks awesome and has a really smooth finish. And that helps hide any layer lines, but does the surface texture make it a little bit weaker. I'm guessing the Matte PLA will perform somewhere in the middle between the PLA and the PLA Plus. So let's get these tested. Remember, always safety first. Let's start with the PLA and see what it can handle. That was definitely interesting. It bent, but it didn't quite break. We see there, it started breaking at the bottom, but it really bent. Actually, the PLA held up better than I thought it would. Now let's try the matte PLA. Okay, PLA Plus. We hear it cracking. Okay, this is the Rapid PLA Plus. Okay, I'm going to be really honest here. I did test other PLA, a different brand, and it snapped. These actually held up a lot better. This DEEPLEE stuff held up a lot better. I mean, it eventually cracked. I mean, you heard it. But, and I'm going to have to review the footage to see at what, at how many newtons each one cracked. But we saw it crack. I'm actually really impressed with this DEEPLEE filament. I was actually thinking it would crack like the other PLA. I was actually shocked. This actually held up. These were bent. So the DEEPLEE actually performed pretty well. But let's look at the footage and let's see what how many newtons each one of these cracked at. So I went back and looked at the footage to see exactly where the first crack started forming with these bridges, and I was a little bit shocked at what I found out. Here's the results. The PLA was 37 newtons, or 8.3 pound force. The PLA Plus, 39 newtons, or 8.8 pound force. Rapid PLA Plus tested. Same way, 39 newtons, or 8.8 pound force. Now the surprise in here was the matte PLA. I figured it would perform slightly the same as the PLA, but it performed really well. The matte PLA performed at 41 newtons, or 9.2 pound force. So what does this mean for your 3D prints? If you want a little bit more strength and durability, you're going to want to go with the PLA Plus. The matte PLA, though, held up really well. I am going to do another test in the future with a different design to see what happens. I'm actually sort of shocked about this one still. I actually thought it was going to perform weaker than the PLA, I'll be completely honest. But the PLA still took a decent amount of load for the actual part. And like I said, in comparison to the other brand of PLA, this one actually held up quite well. So let me know in the comments what other tests you'd like to see. Maybe next time we'll go a little bit bigger on it. And I'd like to thank our friends over at DEEPLEE for sending us the filament in order to do these tests. This was not a sponsored video. They just sent us the filament in order to make the video itself. I'm still pretty shocked this didn't snap and just bend. It's actually really impressive. For more on 3D printing, DIY, and maker projects, make sure you like and follow Maker Build It. And remember, keep on making.